Welcome to our channel Sankalp Study Success. In this video, we are going to learn about random sampling and sampling distributions. What are the random sampling and what are the types of sampling distributions are there? Those all we are going to study in this video. So, let us start with some of the terms we have here, which are population, sample, etc. So, what is population? A large collection of individuals or objects or numerical data. It may be large collection of individuals, objects or numerical data. It may be finite or infinite. Though that is called it is population. Here, population consisting of finite number of objects is called finite population, and population consisting of infinite number of objects is called as infinite population. So, number of observations in the population. How many number of objects are present? So that is nothing but number of observations, right? That is called size of the population, and it is denoted by capital N. Capital N is denoted as size of population. So this is about population here. Now coming to the sample, finite subset of population is known as sample. Sample is nothing but it is a subset of population. So here, number of observations on the sample is called size of sample, and this is denoted by small n. Size of sample is denoted by small n, and size of population is denoted by capital N. So this is about population and sample. Now let us see small and large samples. When do you say a sample is a small sample and a sample is a large sample? So let us see here. If n is less than 30, what is n? Size of sample, right? Size of sample is less than 30, you will call it as the small sample. If size of n is greater than is equals to 30, you will call it as large sample. So here we are having some parameters. What is a parameter is just a statistical measure obtained from the sample. That is also known as statistics. Okay. Now coming to the note, parameters refer to population and statistics refers to sample. Here parameters will refer to population and statistic will refer to sample. Now mu, sigma square, sigma and p. What are all these? Mu is nothing but population mean. Sigma square is population variance. Sigma is population standard deviation, and last one is small p, which is nothing but population proportion. These are related to population terms. And if you take S square, it is sample variance, and if you take S, it is sample standard deviation, and if you take capital P, it is sample proportion. And here we are also having X bar, that is nothing but sample mean, right? Yeah, it is sample mean. So these all are related to sample and these all are related to population. We will denote it in this way. Population mean is denoted by mu, population variance is denoted by sigma square, population standard deviation is denoted by sigma, and population proportion is denoted by small p. Coming to the sample mean, it is denoted by X bar, sample variance is denoted by S square, sample standard deviation is denoted by S, and sample proportion is denoted by capital P. So now, coming to the types of sampling, there are 4 types of sampling. Here we are having random sampling, simple sampling, purposive sampling and stratificial sampling. There are 4 types of sampling we have. Those 4 types are these. So now let us see what is sampling with replacement. Sampling with replacement means same unit of population may be included in each of the sample more than once. That means we are again and again we are replacing it. That means what? Let us take one of the example. Let us consider all samples of size 2. Let me write here. It is an example of size 2. We are considering samples of size 2. that can be drawn with replacement, because here sampling with replacement, right? So we can draw it with replacement, consisting of the numbers are 1, 3, 5 and 7. So by using these numbers 1, 3, 5 and 7, the size is 2. So how can you write 1, 1, 1, 3, 1, 5, 1, 7? Then it is 3, 1, 3, 3, 3, 5 and 3, 7. Then 5, 1, 5, 3, 5, 5 and 5, 7, right? Again with the 7, 7, 1, 7, 3, 7, 5 and 7, 7. So that means we are having 16 possibilities. That means sampling with replacement. That means what? It will give 16 for the 4 numbers which we have taken, and the size is 2. So we are getting 16 possibilities. So this is sampling with replacement. Now let us see what is sampling without replacement also. Here, before that we will see a note. If n is the size of population and small n is size of sample, then number of samples with replacement will be n, capital N to the power of small n. That means let's see with the formula also whether it is correct or not. This is nothing but capital N, right? Here capital N is equals to 4 and small n is equals to size is 2. Small n is equals to 2. So according to the formula, capital N to the power small n, 4 square, which is 16. So we got the same answers. That means what we have done is correct. Now let us see what is sampling without replacement. Sampling without replacement means same unit of population, it is not included in each sample more than once. That means it is included just only once. Let us consider the same example, but we will do it without replacement. Okay, so size will be 2 and the numbers are 1, 3, 5 and 7. So now you cannot include 1, 1 because it is coming more than once. 1 is repeating more than once, right? So you can take only 1, 3, 1, 5 and 1, 7. Then you can take 3, 5 and 3, 7. And you can take 5, 7. So that means 3, 4, 5 and 6. We are getting only 6 possibilities. So this is sampling without replacement. So let us see the note where capital N is size of the population and small n is size of the sample. If it is drawn without replacement, then the formula is capital NCN. Let us check with the example whether it is correct or not. See here, capital N is 4 and small n is 2. Capital NCN, that is 4C2. What is the value of 4C2? It is 6. That means whatever we got is exactly correct. So let us see what is sample mean and sample variance, sample standard deviation. Let us see these terms. What is sample mean? See here, x1, x2 and so on up to xn are the n observations of sample. There is a sample and that for that sample you are having some n observations. Then mean of the sample, it is denoted by x bar. So how can you write x bar is the sample mean, which we have seen already. It is denoted by x bar and it is summation of I is equals to 1 to n xi divided by n. This is nothing but the formula. We are just adding all the numbers. That is nothing but sum of observations by number of observations also. So we are done with the sample mean, right? Now sample variance. Again, these are the n observations of the sample. Then how do you denote sample variance? With s square. S square is equals to sigma I is equals to 1 to n xi minus x bar whole square by n. This is nothing but standard sample variance. Okay, this is the formula of sample variance. Now we are going to see what is sample standard deviation. Sample standard deviation is nothing but square root of the variance, right? So we will write the variance formula as it is. we will just give a square root to this. So this is the sample standard deviation. Now standard error of statistics. This is with replacement. Now let us see. Standard deviation of sampling distribution of statistic, it is known as standard error. We can also say that it is standard error, and it is given by sigma by root n. So it is the formula. All these formulas are very important and you have to remember each and every formula here. Now coming to the finite population, till now we have seen all sample mean, variance and standard deviation of sample, right? Now let us consider finite population, and here finite population of size capital N with mean is equals to mu and standard deviation is sigma. Now we are taking all the possible samples of size n without replacement. Then what do we get? Mean of the sample distribution will become mu. Mean is mu actually, so it is mu only. Now variance of sampling distribution of mean for capital N is greater than small n. Then variance will become sigma square by n of capital N minus small n by capital N minus 1. This is an important formula which you have to remember. Standard deviation of C, here we have already got what is the variance. If we need to find out standard deviation, it is just we have to keep the square root to the variance, right? So that you will get standard deviation. So by keeping the square root, we got this answer. So now here capital N minus small n by capital N minus 1. This is finite population correction factor. This is the correction factor. We are also having problems on correction factor. So all these formulae of finite population and also of sample mean, sample variance, sample standard deviation are the most important formulas, because all these formulas are used in the problems of in order to solve the problems. All these are very much used, so we have to remember it. Now let us solve the first question. Here it is given that a population consisting of 4 members, 2, 3, 4, 5. Consider all possible samples of size 2. You have to consider of size 2, which can be drawn with replacement and as well as without replacement also. That means in both the cases you have to solve the problem. Now you have to find population mean, population variance, population standard deviation, sampling distribution of means, means of sampling distribution of means, variance as well, standard deviation also. So let us solve one by one. Here given n is equals to 2, 3, 4 and 5. So what is the value of n? N is equals to 4. That means you are having 4 items or 4 objects or 4 members, right? Here first you are finding population mean. Population mean is nothing but sigma I is equals to 1 to n xi by n, right? So you have to just add all the numbers and divide by number of numbers. That means what? Sum of observations by number of observations, right? What is this what is this? You will get here 4 plus 5 is 9 and 9 plus 6, it is nothing but 15 by 4, and 15 by 4 is nothing but 3.5. So you will get the population mean as 3.5. So we are done with the first question. Now we are going to solve population variance. Population variance, it is denoted by sigma square, right? Sigma square. What is the formula of population variance? I is equals to 1 to n. Here xi minus x bar whole square by n. This is the formula. Now by applying this formula to these numbers 2, 3, 4 and 5, you will get 2 minus mean is 3.5 whole square, right? Plus 3 minus 3.5 whole square plus 4 minus 3.5 whole square plus 5 minus 3.5 whole square. Divide by n. That means what? Divide by 4. So if you solve this equation, that means if you simplify this, you will get it as 1.25. So sigma square is equals to 1.25. That is nothing but population variance. So this is the second one. Now we are going to find out population standard deviation. Now in order to find out population standard deviation, it is better to just keep square root to the variance, right? Third one is, which is nothing but sigma, that is sigma square root of sigma square is nothing but sigma, right? What is the value of sigma square? 1.25. So square root of 1.25, what is the value? 1.18. So sorry, 1.118 is the value. So this is the value of standard deviation. Now what is the, we have done with all the three here. Now sampling distribution of means, you have to find out the sampling distribution of means. Here first we will find out with replacement. Okay, here we will write it here with replacement. You are going to find out sampling distribution of means with replacement. That means we are having 2, 3, 4 and 5, and the size should be 2, right? Here capital N is equals to 4, small n is equals to 2. That means how many do you get? Capital N power n is 4 square is 16. 16 possibilities you will get. What are those possibilities? Let us write here 2, 2, 2, 3, 2, 4 and 2, 5. Here again 3, 2, 3, 3, 3, 4 and 3, 5. Now 4, 2, 4, 3, 4, 4 and 4, 5. 5, 2, 5, 3, 5, 4 and 5, 5. So these are the 16 possibilities with replacement. This is called sampling distribution. This is sampling distribution. What do you need to find out actually? Sampling distribution of means, right? That means each sampling distribution, for each and every sampling distribution you have to find out mean. That means what? 2 plus 2 divide by 2, 2 plus 3 divide by 2, 2 plus 4 by 2. In the same manner, similarly you have to find for 16 possibilities. That means sampling distribution of means is as follows. So let us see here. 2 plus 2 is nothing but 4. 4 by 2 is again 2. 2 plus 3 is 5. 5 by 2 is 2.5. So in this way you have to find out the means. I am writing directly here. 2.5, 3, 3.5, 4, 3, 3.5, 4, 4.5, 3.5, 4, 4.5 and 5. These are the sampling distribution of means. Now you have to find out, these are the sampling distribution of means. Now you have to find out the mean of this, right? Which is, see here, sampling distribution of means you have found. Now means of sampling distribution of means, that means what? You have to find the mean of this. That means fifth one, mean of sampling distribution of means. That means mu is equals to, you have to add all these and you have to divide by 16. That means 2 plus 2.5 plus 3 plus 3.5 plus and so on. You have to add up to 4.5 plus 5 completely and divide by 16. So you will get this value as 3.5. This is the mean of sampling distribution of means. And now coming to the sixth one. What is the sixth one? What is the sixth one we have? Variance of sampling distribution of means. You have to find out the variance. That means what? Sigma square x bar, right? Because it is a sampling distribution. So here sigma square of x bar, that is 2 minus 3.5 is the mean whole square, plus 2.5 minus 3.5 whole square, plus and so on like this up to 5 minus 3.5 whole square and divide by 16. This is the variance. So you will get the value as 0.625. This is the variance. Now we are going with the seventh one. This is what standard deviation of sampling distribution of means. That is nothing but you can just keep the square root to this, right? That means what? Square root of 0.625 is the answer. What is the square root of 0.625? Which is nothing but 0.7905. This is the answer. So in this way you have to find out each and every problem. So here a population which is consisting of 4 members, 2, 3, 4, 5, and you are considering the size as 2, so that with replacement and without replacement you are just finding all the values. Okay, this is the first problem which you have to find out. Now let us see next problem, which is the same problem. In the same way you have to solve the problem, but we will just see it once. A population consisting of members 2, 3, 6, 8 and 11, and here size is given as 2. Now how do you find out the population mean? First one, in the same way, how do you find out the population mean? 2 plus 3 plus 6, 8, 11 by 5, right? What does this become? This is 11. 8 plus 2 is 10, plus 11 is 21. 21 plus 6 is 27. 27 plus 3 is 30, right? 30 by 5. 5 6 is 30, correct? 5 6 times is 30, no? So population mean, we got the population mean as 6. Now the second one is population variance, that is sigma square, that is 2 minus 6 whole square plus 3 minus 6 whole square plus 6 minus 6 whole square plus 8 minus 6 whole square plus 11 minus 6 whole square by 5. So if you solve this, you will get the value as 10.8. So the population variance is nothing but 10.8. Now you have to find out population standard deviation, which is the very easiest one. How do you find out? You will just add the square root to the variance. So square root of 10.8. Square root of 10.8 is nothing but 3.286. So this is nothing but the population standard deviation. Now with replacement and without replacement. So here we are doing with replacement with the sampling distribution of means. So how do you do is with replacement, and we are having the values as n, capital N is equals to 2, 3, 6, 8 and 11 are the values, where capital N is equals to 5 and small n is equals to 2. So you will get 5 squared, that is 25 possibilities you will get. What are those possibilities? Let us write here: 2, 2, 2, 3, 2, 6, 2, 8 and 2, 11. Here 3, 2, 3, 3, 3, 6, 3, 8 and 3, 11. So in this way you are going to write all the 25 possibilities of with replacement, right? This is with replacement. 6, 8 and 6, 11. And then if you write it with 8, is 8, 2, 8, 3, 8, 6, 8, 8 and 8, 11. And here 11, 2, 11, 3, 11, 6, 11, 8 and 11, 11. So in this way we are going to write all the sampling distributions. So now how do you find out the sampling distribution of means? Here, which is nothing but 2 plus 2 by 2, 2 plus 3 by 2. So let us write, or sorry, completely gone somewhere, right? So now let us see the sampling distribution of means here. So 2 plus 2 by 2 is 2, then it is 2.5, then again 4, 5 and it is 6.5. Now 3, 2. 3, 2 is nothing but 2.5, 3, 4.5, 5.5, 7, 4.5, 6, 7, 8.5, then 5.5, 7, 8, and it is 9.5. Here we are having 6.5, 7, 8.5, 9.5 and 11. So you have to find out all the means of the sampling distributions. So we are done with finding the means of the sampling and also sampling distribution of means. Now you have to find out mean of all that sampling distribution, right? This is the fifth one. Now you need to find out the sixth one, which is you have to just add each and everything and divide by 25. That means 2 plus 2.5 plus and so on up to 11. That is divide by 25. Then you will get the value as 6. Okay. Now the seventh one, you have to find out the variance, right? Variance is nothing but 2 minus 6 whole square, 2.5 minus 6 whole square, plus and so on up to 11 minus 6 whole square by 25. If you solve this value, then you will get it as 5.4. This is nothing but the variance. So here, and the eighth one is standard deviation of x bar. This is the very easy because you have to just add square root to the variance, which is equals to square root of 5.4. Square root of 5.4 is nothing but 2.32. So this is the value. These are the values of the second solution. So which is very important, and you have to solve it because you may get it for a long answer. That is, it may be for 7 marks or it may ask for 10 marks also. So now we are going to solve a small problem here, which is of different model. Here a sample of size 400. It is taken from the population whose standard deviation is 16. That means we are given standard deviation and also size of the sample. Then you have to find standard error. See, we will write the given information first. Given n is equals to 400. And here standard deviation, which is nothing but sigma, right? Sigma is equals to 16. Now you have to find out the standard error. Standard error is denoted by sigma x bar, which is nothing but sigma by root n. This is the formula. Sigma is nothing but 16 and root n is nothing but 400. So here, if you simplify, you will get it as 0.8. This is the standard error. You will get this type of problems for 1 mark question in the external exam. So you have to concentrate on these questions as well. Let us see one more question, which is here sample of size 169. That means what? Given n is equals to 169, right? And it is taken from the solution whose variance is 2. Here variance is given. Previously it was standard deviation. Variance means what? Sigma square is equals to 2. And here from variance you can find out sigma, right? Sigma is nothing but square root of 2. So here you have to find out the standard error. We know the formula of standard error, which is equals to sigma by root n, right? So what is sigma? Root 2 by root n is nothing but root 169. That is nothing but square root of 2 by 169. That is what? Root 2 by square root of 169 is 13, right? That is equal to root 2 by 13. So if you solve this value, you will get it as 0.108. 0.108 is the value. Okay. So in this way, you have to just remember the formula and substitute the given values into the formula so that you will get the answer. So let's see the last problem of this video, which is, you may also get it for 1 mark. This question is also very important. Here given n is equals to 5 and population size is 200. Population size is denoted by capital N, right? Which is equals to 200. Now you have to find the correction factor. What is the formula for the correction factor? You have to remember each and every formula. So correction factor is equals to capital N minus small n by capital N minus 1. This is the formula. Here we know what is capital N and we know what is small n. So let us substitute all the values in the formula and we will get the answer. 200 minus 5 by 200 minus 1. 200 minus 5 is nothing but 195, right? 200 minus 1 is nothing but 199. So if you divide this, you will get 0.9798. So this is the value. So this is the correction factor. Here you have to remember each and every formula, and it is the very easy concept where you will apply the formula and just you will substitute the values in that. So this is the video. Let's meet in the next video.